Hey there, welcome back. I'm glad you're here. Today, in middle school math with Dr. K, we're talking about the distributive property. Let's jump right in. So the distributive property, it's a concept that we use when we're simplifying an expression, and then eventually we use it when we're solving an equation. So I want to talk about what that is and give you some real life context to go with it first. So imagine this. You are headed to a party. You are not in the doors yet, but you are a talker. You are an extrovert. You want to talk to everybody involved in this party. So this is you. Now, as soon as you walk in those doors, you are going to talk with your two friends that are in the doors. You're going to talk to this person for a while, and then you're also going to talk to this person. So when you left, you have talked with everybody inside that party. Now that is the distributive property in a nutshell. Whatever's on the outside goes with both of the things on the inside. In an actual algebraic expression, the thing on the outside is multiplied by the things on the inside. So let's take a look at that. Example 1 has 5 multiplied by the quantity 7x minus 4. Now, back to that social context, 5 is the person outside the doors. 5 wants to talk with both 7x and this minus 4 over here. So in an algebraic expression, the 5 needs to be multiplied by both of those pieces. 5 times 7x, or 5 groups of 7x, gives us 35x. 5 times 4, or 5 groups of 4, gives us 20. Because there was a minus sign originally, we're going to bring that down into our answer, and we have here a simplified expression. Example 2 is a little bit different only because the number on the outside of the parentheses is a negative value, and we need to talk about how you distribute a negative into minuses and pluses and so on and so forth. Now, negative 3 needs to be multiplied by 7x and needs to be multiplied by 4. So let's take a look at how that works. Negative 3 times 7x is, of course, negative 21x. Negative 3 times 4 is negative 12. However, if I treat this problem just like I treated the last problem, I need to bring this minus sign down into my problem. And I get something that's not exactly simplified. Negative 21x minus negative 12 can be simplified further, dealing with the two negatives that happen right in a row. Now, we learned back in our integer rules, we've been working with rational numbers, we've learned about the additive inverse. Anytime you have a minus sign, you can rewrite the problem using a plus sign. You can do that as long as your first number stays the same, and then you change the minus sign to a plus sign, and you use the additive inverse of whatever comes next. The additive inverse is a fancy word for opposite, and the opposite of negative 12 is 12. Once I change my negative 21 minus negative 12 to negative 21 plus 12, I have fully simplified this expression. Now, there is a little bit of a shortcut for this. When you're distributing in this problem, negative 3 times 7x minus 4. Negative 3 times 7x is pretty straightforward, negative 21x. But some people like to think of this as a negative 4. Negative 3 times negative 4 is positive 12, so I can write plus 12. That gets you to the solution a little bit faster without so much simplifying. So if you want to think of this minus 4 as a negative 4, that's actually a really helpful skill that can get you to the solution or the simplified version of the expression a little more efficiently. Now, where we're headed is using distribution in combination with combining like terms and simplifying expressions. So here's an example of that. Here I have negative 2, and then in parentheses I have the quantity 4 minus 2x, and then after the parentheses I have a plus 8. Now when you're distributing, the number, the negative 2 that's talking to everybody at the party, is only talking to the numbers that are in the parentheses. So the negative 2 is getting distributed to the 4 and to the 2x, but not to the 8. That's important information. If it's not in the parentheses, it's not included in the party. It is not... It's not part of the distribution that's happening. So let's multiply. Negative 2 times 4 gives you negative 8. Now, negative 2 times 2x is negative 4x. But remember, we're going to think of this as like a negative 2x. We're going to rope that minus sign in with our 2x. Negative 2 times negative 2x is positive 4x. So when we use that minus sign like it's a negative, we can more simply, more quickly, more efficiently get our signs all shored up. Now I'm going to bring down the plus 8, so nothing has really happened with that. It was just a part of the problem and now it's here. Where I go from here is combining my like terms. So I look in my problem and I see that I have a negative 8 plus 8, and negative 8 plus 8 I know is 0. So these terms effectively cancel each other out, leaving me with only 4x. I distributed, I simplified, and my most simplified version is 4x. Here's an example where I still have an extra piece that's not a part of the distribution, but this time it's in front. Now, think back to order of operations. We do parentheses, exponents, multiplication, division, addition, subtraction. Now, the order of operations actually works in expressions just like it would work in a numerical problem. So the first thing I would look for are parentheses, and I do have parentheses, but there's nothing I can do with that x plus 4 because they're not like terms. So let's forget about parentheses. I don't see any exponents, but I do know that there's multiplication. I might not see it clearly, but when we have distributing, we have multiplication. So the next step would actually be to distribute this 5 to both pieces. Now, just like before, because we have a minus 5, we're going to treat it like it's a negative 5 when we distribute. My 3x will just stay in front for now, so I'm bringing that down into my answer. Negative 5 times x is negative 5x, or minus 5x. Negative 5 times 4 is negative 20, or minus 20. Now you'll notice that I am switching kind of back and forth between a negative and a minus. So sometimes I have a minus 5, like in this example, and I consider it a negative 5 when I'm distributing it. And maybe I multiply and get a negative 20, so I write it as a minus 20 when I write my expression. Now, what we're learning through this process is that a negative and a minus sign are relatively interchangeable. There's not actually a difference between the two things. Up until this point, you might have asked your teacher, or me if I'm your teacher, is this a minus sign or is this a negative? And what we're learning now is that those are the same thing. They really represent the same quantity. Now moving forward, we're going to look for our like terms. I see that I have a 3x and a minus 5x, which are my like terms. 3x minus 5x, as I know, is negative 2. And because that minus 20 has no like terms with it, it's going to just be included in my answer just as it was. So I have negative 2x minus 20 as my fully simplified version of our starting expression. This video should have given you a quick rundown on using the distributive property. The basic idea is that if there's a number outside of parentheses, that number needs to talk to or needs to be multiplied by everything inside the parentheses, and that's distributing. It doesn't matter if the number outside is negative. It doesn't matter if the operation inside is subtraction. What matters is that you take this number and multiply it by everything in the parentheses. I've shown you examples of having 2 terms in the parentheses, but you could also have 3 terms. You could have different variables. You can have any combination of these things. What's important to note about the distributive property is you distribute across addition and subtraction, and that means you're not going to see distribution that has a number outside of parentheses and no plus or minus sign in the parentheses. That's not actually an example of when you would use distribution. That would represent just multiplication. Now, go, distribute, enjoy your life, and thanks for being here. I'll see you next time.